Welcome, everyone. Thank you for attending today's HIMSS Learning Center webinar, How Massachusetts eHealth Collaborative Migrated to AWS, sponsored by Datavail. I'm Susan Morse, Senior Editor of Healthcare Finance, and I'll be your moderator today. In this webinar, Massachusetts eHealth Collaborative will guide you through the steps they took to migrate their SQL database applications to the AWS cloud. You'll learn how they built a compliant AWS cloud with Datavail and Logicworks, both AWS Premier and Advanced Consulting partners, specializing in secure, compliant AWS cloud services for database and infrastructure. Our panelists for today's discussion are Zoltan Disnik, Solutions Architect at Amazon Web Services, Donovan Brady, Solutions Architect at Logicworks, Siva Tangavalu, Director of Cloud Practice at Datavail, and David Delano, Principal Consultant at Massachusetts eHealth Collaborative. With that, I'll hand it over to Zoltan to begin the presentation.
Hello, everybody. My name is Latson. I'm a Solution Architect for Amazon Web Services. And I'm going to give you a bit of an intro about AWS and running Windows and SQL workloads on AWS. So let's begin. So why are Microsoft workloads moving to the cloud to begin with? So these are one of the, some of the core cloud questions, that really apply to everything, not just Microsoft workloads. Reduce burden to IT staff, enable more rapid scalability, and lower, obviously, cost. We are drastically all the time trying to lower as much of the cost as possible. So this further really kind of translates into accelerating innovation. If we are able to automate as much of your workloads and provide you with as many services that can actually further reduce the complexity of your workloads, migration of the same workloads, or improve actual DevOps and time to market specifically, that way we will end by lowering the cost at the same time. We can actually give you a lot more funding, a lot more time, a lot more resources to invest in further innovation and accelerate it, right? We can obviously reduce costs due to the massive scale that we have as a leading cloud provider, and we can strengthen your security posture. The security is really ground zero for us. That is something that I think we're well known for as well, and something that is first and foremost when it comes to any architecture that people put forward. Our availability options, availability zones, and just the power, services behind it, as well as infrastructure and platforms and services that we have to offer on top of that. And you can easily manage and scale up or down as your demand grows, as your business grows, and as you need to. Whether that's scaling by means of scaling the actual infrastructure that you need, or licensing that you may want to temporarily use without increasing your license and hardware investments, and generally your capital investments. In general. So how do we accelerate innovation? Well, we provide you with access to the broadest and deepest set of cloud services. I mean, we started off, I think even if I look at back in 2011, it was around 80, and then we went to 150 the next year, and the next year, and the next year. We actually released around 1,500 services last year alone. Services and features last year alone, and we keep on kind of adding to this innovation pace. 95% of which actually comes from customer feedback and from both our customers and our partners, and we feed that and use that to basically fuel our innovation. You can provision all these resources on demand, and you can eliminate these lengthy procurement processes and all that sort of stuff. So you don't have to worry about, never mind buying the super expensive hardware, but also maintaining it. You don't have to worry about upgrading it. And most of all, you don't have to worry about deployment cycles and how quickly you can actually get something out to market as soon as possible. You can establish a global footprint literally without the cost of time associated with building new facilities or anything like that. All of these things are already at your disposal. We already have ways on how to help you proliferate and expand, your application investment, the entire application portfolio globally at any given point in time. You can integrate any emerging technology, things like artificial intelligence, machine learning, Internet of Things, with a lot less risk. That is much easier to use. That doesn't require as much core expertise on your side as possible. You can leverage these skills that we have to provide for you, and you can leverage the investments and services that we have made at your disposal. You can focus on customer value instead of just consuming hardware maintenance or buying licenses and spending copious amounts of money, on both resources, hardware and licenses and all these, and everything that comes associated with it, right? As well as the time taken to take care of all of that. So all of that can go into innovation. So reducing costs, I think, I kind of reiterated that several times, with respect to, first of all, us running at a massive scale and being able to offer really low cost, on our hardware and services. So I think we've reduced our prices over 60 times since the beginning, and we continue to reduce our prices on hardware and services that we provide. We can actually provide you with application performance, with improved application performance without you having to worry about hardware refresh and the cost of hardware refresh to do that. So we will provide you with the latest hardware, with the latest platforms, and latest concepts, without you having to invest in acquiring it, installing it, migrating to it, or refreshing it for any reason. So you can strengthen your security posture. I mean, we have compliance. You can actually take a look at security posture and security compliance on our website. We have everything from FISMA, ITAR, SOC 1, SOC 2, SOC 3, various different HIPAA and various different compliance for our services and platforms. We have ways of obviously helping you achieve that with your solutions that you build on top of our platform. We have many different, architectures and approaches on how to do that effectively. You can bring in the existing Microsoft, Active Directory. You can bring in and use your credentials and use your AWS IAM. Through federation, you can protect any in-transit data or at rest with both encrypting communication and encrypting data at rest. And you can leverage also any third-party security solutions that you may like from existing or other providers, existing ones that you may be using right now, and new providers that you may want to use from our AWS marketplace, which I really encourage you to check out. You can improve uptime and performance. Basically, just looking at our availability zones. Our availability zones are clusters of data centers that are on a different, they're geo-displaced on a different floodplain, different fault plane. Not the same natural disaster can affect it. They have different utilities. They have different everything, and they basically operate as one with minimal latency between them. So that means if you have a multi-AZ deployment of your application, that really counts as what would traditionally be a very expensive and full-on disaster recovery solution. You have a variety of EC2 instance types that you can choose from, you can very easy with minimal downtime, even vertically, scale if necessary, change these instances, provision perhaps more IOPS, increase sizes of your drives, add more, CPU and RAM power, and you have also different types, from compute to memory optimized, storage optimized, and so on. And you can immediately respond to, like I said, to any changing, resource requirement that you may have from any incoming traffic or usage through by means of our auto-scaling elastic load balancing. Those are these industry standard services that run all these massive solutions that you well know that run on top of our platform. And you can maintain full visibility, just through a single pane of glass of all that is happening. You can automate all of that, and you can basically, just as easily inform and keep everybody in touch of any, relevant aspects of, uptime and performance of your solution. You can easily manage and scale. So you can extend your existing investments in tool sets. You can actually replace any more complex and deprecated part of your solutions with our actual compliant and performance solutions, our serverless services, that can, that also, a lot of them are compliant, and they can help you further actually simplify the solutions that you currently have, as well as help you migrate to more cloud-ready solutions, right? Very easily without you having to even worry about, in case of serverless, without you having to worry about managing infrastructure availability or scalability aspects of it. You can leverage automation and everything from automating on how infrastructure gets created to infrastructure as a code to CDCI pipelines for your solutions and for your products. And those can dramatically actually increase your time to market, specifically, by automating and then in leveraging the performance of our services for this automation, right? So you can also tap into our partner network. We have amazing partners like Datavail that is going to be talking to you today for migration and managed services. And you can receive the same support from Microsoft as you do for your on-premises Microsoft solutions. In fact, we will even support some of the deprecated basically platforms that Microsoft doesn't support anymore, like Windows 2003 and so on, for you. Obviously, we don't provide any patches, but we will help you run those things on our platform. So now it's time for a poll. Can you please describe the current state of your organization's cloud utilization, and please select the most appropriate answer for this. So I'm going to give you guys a little bit of time to go ahead and do this. So thank you so much for your responses. We're going to now move on and push forward. Now you can actually see the results of our poll. I can see that the most of you on the webinar are using some kind of cloud infrastructure with most infrastructure currently in the cloud, being close second, and the third last one, or second to last, most infrastructure is currently on-prem or in colo facility. Okay. Those are actually pretty good numbers considering. Thank you for that. So what are the options for deploying SQL Server on AWS? So we have many massive deployments of SQL Server on AWS, and we have a lot of both development or smaller deployments, and literally everything in between, right? So we are really able to accommodate any type of SQL Server deployment that you may need in the cloud, and we are able to assist you with that, provide different levels of service to further automate and help you manage these options. Obviously, the first one being Amazon RDS or SQL Server is a fully managed option as part of our Amazon Relational Database Service. For that one, you don't have to worry about scaling, high availability, database backups, DBMS patching, install and maintenance, or OS patching. And basically, we take care of everything for you on that side of things. So you can have a fully available implementation of full-blown SQL Server. Obviously, if we are responsible and we provide managed services for you, that means that the system and file system or file level access or file system level access, we cannot give you access to that. So for any kind of system access that will require, for example, for you to get any reports that you may need or any logs that you may need or anything like that, we have actually created SOAP procedures that you can use. And that also includes making backups directly to S3, which then can be pushed over to something like a Vault Glacier, which for much storage and infrequent use as well, so for much cheaper storage and infrequent use. So giving you a very kind of cost-effective and easily manageable tool over here. However, things like third-party components, something that requires file level access or direct access onto the SQL node and stuff, will not be compliant with RDS for SQL Server. You can also use basically you will be renting our licenses, and you don't have to use any of your licenses to use fully managed SQL Server through RDS. But if you want to manage the scaling aspect, if you want to create your own high availability, if you want to use your always-on availability groups, and let's say you want to use it across, you want to use distributed always-on availability groups between two always-on availability groups, to mixed platforms using, clustering on Windows as well as clustering on the Linux side of things and all this sort of stuff, or you're dealing with implementations that require to have direct access to the server, as well as third-party components where, let's say, you have stored procedures that need to have file system access because of third-party components that they're using, then SQL Server on Amazon EC2 directly is the best choice. Yes, you are managing scaling, high availability, database backups and DBMS patching and install and maintenance. However, we do have several ways of automating most of these operational tasks for you by means of using something like AWS System Manager and automation, through CloudWatch events and Lambda and many other different aspects. We can make this, and offload as much of these operational tasks directly off your back, and make it a lot easier for you to manage, and of course a lot cheaper too. Some of the best practices of running SQL Server on AWS, and first thing is, from a deployment perspective, we have infrastructure as a code, CloudFormation. In fact, if you right now go to AWS, put in search AWS and Quick Start, you will be able to see Quick Start for SQL Server, and that's a full-blown CloudFormation that deploys actual full full-blown production-ready SQL always-on availability cluster in full sync mode, and you can just start using it. There are two types of drives that you can use. You can use the provision IOPS SSD. As you can see, it has maximum throughput as well as a maximum IOPS of 32,000 for whatever.
Hi, I think we lost Zlatan. I'm going to pick it up from here. Zlatan was talking about how to optimize 10 just like an on-premises. So for 10 we typically specify a volume size of 1 GB to like 100 GB in size, and we recommend EBS volume type like GP2, which can provide a maximum IOPS of like 10,000 and provide burst IOPS of like 3,000. As you can see, you can choose the disks that are required for the IOPS you need, both for transactions and also to put the data files and also the 10 DB files. Now, coming to the licensing option in AWS, when it comes to SQL Server or running Windows, you have two options you can choose in terms of licensing. The first option is license included. Legacy versions are available in AWS Marketplace, and you can go to the AWS Management Console and buy the licenses directly from there. These licenses costs are included as part of the AWS bill, and this is purely a subscription-based model. In this case, AWS handles all the licensing and compliance that's required. There is an option where you can benefit from bring your own licenses. You can use license mobility through software assurance from Microsoft or from any other provider, and you can bring your own licenses to your Amazon EC2 dedicated host, or you can bring it to regular Amazon EC2 hosts. In this case, the customer is responsible for maintaining the license compliance and also the requirements. The other advantage of extending the license investments to the cloud is you pay only for the AWS services you consume. So you can choose between either bringing your own licenses or choose the license included model in the AWS. Now we are going to conduct a very quick poll in terms of which database platform you're using in your environment. So I would really appreciate if you can take 30 seconds or 20 seconds to answer this question. Thank you for answering this poll question. This is the results of the database platform every customers are using. Microsoft SQL takes the first place in our poll with 18 people answering as for Microsoft SQL Server, and Oracle takes the next, and then the third is the MySQL, and the fourth is the other database platforms. In this presentation, we are going to present how Logicworks and Datavail collaborated with Massachusetts eHealth to build a HIPAA-compliant environment in AWS. As you know, Zlatan talked about the advantages of running Microsoft workloads, more specifically SQL Server workloads on AWS in terms of performance, security, innovation, HA, and also in terms of licensing. Now, in this case study, we are going to present how Massachusetts eHealth benefited from the design and build and also the data migration methodology we implemented as part of this migration process. So in this presentation, we're going to start with giving brief introductions to Datavail, who is a database migration service provider in this project, and Logicworks, who is the infrastructure and design builder for this project, and also short introduction to Massachusetts eHealth. Following the introduction, David Delano from Massachusetts eHealth is going to talk about what are the business drivers for this migration from his data center to the AWS facility. And also he's going to talk about why choose AWS as a cloud database platform. Following that, he's also going to talk about how Logicworks and Datavail came up with the migration approach and how that was executed. Following that will be a detailed discussion of how the infrastructure was designed and built in the AWS environment in an automated fashion. And Donovan Brady from Logicworks is going to get into the details of that process. Following that, Siva and myself, I'm going to talk about the database design and build in the AWS environment. And also I'm going to spend quite a bit of time talking about the data migration methodology we implemented and also some of the HENDR methodology we implemented. And then we're going to end the presentation with some of the post-migration activities we carried out. Datavail. Who's Datavail? Datavail is one of the largest remote database administration company in North America. We have over 1,000 DBAs, consultants, and cloud engineers working across 4 different countries. In Datavail, we provide consulting services for cloud in terms of cloud database migration across all different database platforms. That includes Microsoft SQL Server, Oracle, MySQL, Postgres, and also Aurora in Amazon. We also do cloud optimization after the migration is completed. The cloud optimization mainly includes the well-architected review of your current environment, and also we come up with the best practices and optimization recommendations for your environment running in cloud. We also provide operational managed services for your database environments running in cloud that includes 24/7 monitoring and incident responses. As part of the operational managed services, we also take service requests, which can include anything from upgrade, patching, tuning, security, implement HENDR, etc. We also have a dedicated team which does the data development services, which includes database development, performance tuning, ETL processes, automation, etc. We also have a team that builds the data warehouse and is involved deeply in optimization of data transfers and ETL processes. Again, I'm Siva Thangavelu. I'm the AWS practice lead at Datavail, and my specialty is in database performance tuning, database scalability, cloud data architecture, and cloud data migration. I was formerly a SQL Server DBA, and now I run the cloud practices team at Datavail. With that said, I'm going to hand over the slide to Donovan from Logicworks.
Thanks, Siva, and good afternoon, everybody. My name is Donovan Brady, and I'm a solutions architect at Logicworks. Logicworks is a leader in compliant cloud solutions and an AWS Premier Partner, where we actually provide the full suite of cloud services all the way from migrations to optimization to even ongoing management of your environment. I've worked at Logicworks for just over 4 years, previously as a back-end software engineer and now as a solutions architect, where I use my developer background to design compliant, secure, and highly available environments for our customers. David, would you like to introduce yourself and give us a little background on MAeHC's migration drivers?
Sure, everybody. Thanks for joining. This is Dave Delano. I'm a principal consultant with Massachusetts eHealth Collaborative. And just a little bit about MAeHC Collaborative. We are a nonprofit services firm. We deliver all sorts of strategic guidance, project management, data warehousing, and in particular, we have an analytics services solution called the Quality Data Center, QDC, and that is the platform that we migrated to the AWS cloud under the support and direction of the folks from Datavail, Logicworks, and certainly, obviously, AWS. Our focus is really around a whole bunch of things that we do around HIT and HIE integration. I'm also the privacy and security officer for MAeHC Collaborative. So anything that we do must be HIPAA compliant. I saw a few questions on the chat window around HIPAA compliance. And of course, anything related to PHI, protected health information, has to be and maintain HIPAA compliance even during the migration from our existing or our initial on-prem solution over to the AWS cloud. So it was very important for us to make sure that we did all that securely and we had essentially no hiccups in that process as we were migrating to the cloud. And moving on to the next slide. As I said, my background is essentially now a principal consultant, but also the security officer, and I do have 34 years or so, probably more now, of experience in health information technology, including large-scale systems implementation, integration across multiple disparate trading partners. We have clinical practice operations folks that send us data literally constantly and continually throughout the week, day, minute by minute, that we collect into our quality data center environment. So we move that to the AWS cloud while maintaining our client-based connectivity and services concurrently. So that in itself was a daunting task that we were able to accomplish. The drivers behind our migration, I mean, as what we've really kind of heard a lot of already from Zlatan and from Shiva, is that we had a growing need for dealing with large amounts of data, certainly a tremendous amount of data, up to, I think, 10 terabytes of data ultimately is what we migrated to AWS. And it was growing continually. We had an on-prem solution that was managed through a managed services vendor that we had engaged for those services, but we felt that we had actually sort of outgrown that model. We had outgrown both the on-prem capabilities of our existing infrastructure and some of the capabilities we had for dealing with things like ongoing security improvements, need for high availability and disaster recovery, our flexibility to adapt to the client and industry. So certainly as new services that we're providing are coming online, we needed that flexibility to be able to adapt quickly through the client base that we're dealing with and supporting, as well as to the industry. And then our scale of our organization and the need for shared services was a perfect fit for this model, because we don't have a high depth of technical bench strength, and so we needed to have the ability to tap into a broad and deep bench of expertise, both around some of the things we just mentioned: high availability, security, growth, infrastructure management, upgrades and expansion, as well as cost optimization, and cost optimization really being where we are now. We have a focused effort right now to look at cost optimization across our platforms, and we're finding some great opportunities to adjust our model according to that. Performance was also an issue. We deployed a web-based application to our clients across essentially the United States. We have data from almost every state in the country, and we have clients across the U.S. accessing that environment through secure web portal services that we offer. And performance became a very key factor for us in being able to manage on-prem versus hosted database and hosted solution services. And then lastly, 24/7 monitoring of that environment and giving us tools and capabilities. I think we heard earlier a single pane of glass view into the environment, so we could see what's happening when, where, and what kinds of things we might need to do to adjust to that environment. And then lastly, just the tools and expertise of the team that both Datavail and Logicworks brings to the table to help us kind of navigate those challenges going forward. And so why migrate to AWS? So I think you've kind of already heard some of the stories around this, but certainly that flexibility, the disk space and performance issues we had with storing 10 plus terabytes of data were substantial. I mean, literally on a daily basis, we were reviewing capacity, reviewing growth, looking at where we needed to adjust, add infrastructure, and that meant physical infrastructure, like procuring more storage capacity, integrating that within the environment in a real-time production way that did not disrupt client activity. So, being able to kind of make changes on the fly essentially was a real need for us with this growth. And our growth was somewhat unpredictable. We knew we were going to be adding clients. We've been adding clients for years, but the rate of growth, the amount of data that they'd be sending, and then them bringing more and more data and clients to the QDC environment that we manage was a continual challenge for us, and one that I don't think we were doing particularly efficiently, and so we needed a better way of doing that. Really modernizing both the environment, the infrastructure, the capabilities, the tools, the views, the security footprint, the security ability to manage and track and monitor access logs, all that sort of HIPAA-required tracking activity that folks need to do whenever they're hosting protected health information. That all became much more apparent and visible to us through the new environment. And then lastly, the storage and throughput that we could manage and monitor with tools and then provision as needed within that environment really became, sort of key drivers for our decision making as we chose to go forward with AWS. And then why data? So you say why Datavail and Logicworks? Well, we did not choose. In fact, I don't think it was available at the time. The RDS, the Relational Database Services from Amazon. So Logicworks was our initial managed service company that we chose to help us with the migration as well as the ongoing support and management of the environment that we are hosting within AWS. So, both, so initially started with Logicworks, and then as we identified the need for the data migration and the requirements of that and being done in a secure manner through, several methods, and you'll hear about that during the migration discussion. But it was very critical for us to have both performance and efficient data migration of 10 terabytes of production data. So Datavail was brought in as essentially our DBA or our database experts within the cloud to, kind of help us with the migration activities. And then now with ongoing tuning, performance, monitoring, as well as we're looking at now bringing in some data archival capabilities using Glacier. Glacier you heard about mentioned earlier, which is a nearline storage solution that's much less expensive, but it's available data, just that it's less intensive in terms of access and use and less performance, but you have availability of that data anytime you need it. So both Logicworks and Datavail brought the experience to the table to accomplish that goal, and that really was the ultimate goal, was that migration. Logicworks is really infrastructure design and build and automation, and Datavail brings in the specific Microsoft SQL Server database experience we needed to accommodate the migration with large volumes of data in a production mode with real-time clients accessing and using that data while we were in migration. And I think this is where we're going to turn it back over. I don't know if Donovan's going to pick up from here.
Yeah, definitely. Thanks, David. The three main reasons our customers want to migrate to AWS are directly in line with what David mentioned. They want to achieve cost optimization, high availability, and security. But the way these are achieved are drastically different from a traditional architecture, so naturally it creates a lot of unknowns. These would be things like, how do I right size my instances or create the right instance type? How do I choose the right storage solution? How do I actually design for high availability? So naturally, Logicworks helps them navigate the cloud with greater ease and flexibility to achieve their business goals. When we're architecting a solution for Massachusetts eHealth Collaborative, or MAeHC, we proposed a multi-phase approach, starting with shipping their data to AWS and building their underlying architecture. I'm going to talk about the design and build of the architecture before kicking it off to Siva to go through the database migration. So let's jump in. First, let me ask you a question. If your organization has not yet begun a migration to the cloud, what has kept it from making the transition? Thanks for your participation. It looks like a lot of you guys are concerned with security and compliance with the cloud. So that's great. We're going to talk about that in a little bit so that hopefully we can actually quell those concerns. Here's the architectural details of MAeHC's on-premise implementation. It's a lot, so I won't go through every point, but the key takeaways are that they're a Windows shop who built an application that stored and processed billions of records, and to host it, they're releasing space in a data center, which can obviously get costly. They had compliance requirements as they were storing PHI data, and they had no high availability or DR strategy for redundancy. This last one is really important because it's a key driver for several of our clients moving to AWS, so we really wanted to nail this one. As such, the design that we proposed utilized a combination of AWS auto-scaling groups and CloudWatch recovery instances, enabling a self-healing and hyper-scalable architecture. Secondly, we also proposed using infrastructure as code best practices to build and maintain their environment, which allows for an easily repeatable process when trying to deploy resources in your AWS environment. For MAeHC, we proposed using CloudFormation for resource provisioning and Puppet for configuration management. There are infinitely many benefits to using infrastructure as code. Across the board, firstly, it minimizes the possibility of human error when managing your environment. One common mistake that people make is when you're manually provisioning your resources, it's the order of what you actually deploy. CloudFormation has an inherent understanding of a sequence and will deploy the resources in that required sequence regardless of the order that you coded it in. Another one of my favorites is actually the automated bootstrapping of instances, where instead of having to SSH into your instance and manually install all the required dependencies and requirements, Puppet actually will automatically install these dependencies on boot so that by the time you access your instance, it's already locked and loaded, built to your application's requirements. When MAeHC approached us, they knew how to architect for redundancy and security on-prem, but they didn't really know how to do this in AWS. So we helped them architect and utilize AWS services and best practices to achieve this. One of these is the hub and spoke VPC design. This design represents a logical grouping of your instances by function. For example, your hub VPC would include all necessary tools for management. These would be services such as security tooling, bastion or jump hosts, domain controllers, user management, or really any other management tools that your environment might require. From there, you'd actually build out each spoke VPC to its specific function. Typically, this would be in the tiers of the software delivery lifecycle, like your development environment, your stage environment, production, or even disaster recovery. AWS makes it really easy to peer your spoke VPCs to your hub VPC to inherit the tooling from that hub VPC without having to build them again throughout every other VPC. So this model inherently lends itself to cost efficiency and security. It's secure because you have a secure access point via a bastion host, which is also a HIPAA requirement. So those of you who are scared for moving to the cloud, this is for you. HIPAA compliance, actually, it has so many security requirements that the hub and spoke model actually helps. It minimizes your overall footprint by providing fewer ingress points to your environment. It enables easy aggregation of logs, as well as a whole slew of other capabilities. I won't stay too long on this slide since it just shows you a graphical representation of MAeHC environment, but you can see the hub, which stores the bastion, the Active Directory cluster, the Alert Logic Threat Manager, and Puppet for automation. And then this hub is peered to each environment, which then utilizes multiple availability zones and asynchronous replication to the DBs in production for high availability. As we all know, the cloud is a very different beast to an on-prem deployment. So what we're really good at here at Logicworks is analyzing your on-prem environment and right-sizing your infrastructure for the cloud to ensure all your resources and services are optimized for your specific application. Specifically speaking, the architecture that we implemented was to utilize EC2 instances with optimized EBS volumes across each tiered environment. Even more specifically speaking, if you're interested, the EC2 instances that we used are general purpose M5 X-Large and M5 2X-Large for the web instances, and their databases are hosted on R4 4X-Large instances. Logicworks ensures that after we've implemented a design, all the client has to do is upload their code. In MAeHC's case, we handed them the keys to a HIPAA-compliant, fully secure, and hyper-scalable environment in AWS, enabling them to scale and grow their business. Now, Datavail is going to explain the migration they conducted to optimize MAeHC's databases in the cloud. Over to you, Siva.
Thank you, Donovan. As you heard, Donovan went into the details of building a HIPAA-compliant environment in AWS. The next critical step in this whole migration process is building a HIPAA-compliant database environment, which includes design, build, deployment, and also migrate the data securely, and at the same time, take into account of all the HA and DR needs that the customer was asking. So I'm just going to spend very quick on what was the database configuration that was running on premises. As you can see, MAeHC was running SQL Server 2008 Enterprise Edition on Windows Server 2012 Data Center Edition. I just want to take 2 seconds to remind everyone that SQL Server 2008 R2 is going out of Microsoft support very soon. So if you're running SQL Server 2008 R2, you should be planning on migrating to one of the most SQL Server recent version, which is SQL Server 2017. In this environment, on-prem, they had a standalone server for the OLTP workloads, and the reporting and the data warehousing server were also running as a standalone server. All these servers were segregated into 3 different environments: staging, testing, and dev. There was also an ETL processing that was running from the OLTP server to the data warehouse server. We were using change data capture and replication topology to replicate the data between those 2 servers. As far as the configuration for the servers goes, there was 32 CPU cores and 256 GB of memory. And as far as the data size goes, it was 10 plus terabytes of total data, and the biggest database size was 1 terabyte. One of the challenges, or one of the questions we had during the beginning of this project, was how to transfer the 10 plus terabytes of data from on-premises to AWS in a secure fashion, and at the same time do it in a very cost-effective fashion. So we brainstormed about using AWS Direct Connect or using like Snowball. I'm going to get into the details of that in the next slide. However, I want to show you a very high-level architectural drawing of how the on-prem environment looked like. I'm not going to spend much time there, but as you can see, the database environments, they had 2 different environments. One is prod, dev, and staging environment is within the dev environment itself. As you can see, the database servers are standalone by themselves, and they had issues with like storing 10 plus terabytes of data. So scalability was a major issue. The second issue was there was no HA and DR that were in place. So in an event of failure, you're highly dependent on the backups that were stored in the disks, and the recovery time objective was not being satisfied with the current configuration. So the primary requirements with this migration process was MAeHC wanted a minimum outage during the migration process. Along with that, one of the other requirements was recover a HA recovery site along with the primary site in AWS. So what we did was we followed a unique methodology to transfer the data from on-prem to AWS. Like I said before, we were considering AWS Direct Connect, but because of cost reasons, we decided to ship the full backups through Snowball to the AWS environment. AWS was really great and responsive in terms of like this transferring the Snowball from the on-prem to AWS and also restoring the data. As soon as the data was restored in the AWS environment, we used log shipping to sync the data between the on-prem and the database environment in AWS. Since there were a lot of databases involved, we followed an automation process which was able to automate the whole log shipping from on-prem to AWS, and so that the very minimal manual intervention was required. As part of this whole migration process, we were also tasked with modernizing the database, not only in terms of infrastructure, but also in terms of the version. So we upgraded the SQL Server 2008 R2 to the most recent version, which was SQL Server 2016 at that time. The next step we did was database was synced to the legacy production on-prem, and the database were constantly in sync, and a minimal downtime was taken when we did the final cutover. Also, as a part of satisfying the HA requirements in AWS, what we did was we set up another database server in a standby mode, and we configured high-performance database mirroring so that it serves as a HA site for the primary site. I'm going to get into the details of the high availability stuff in the next slides. So this is the proposed database architecture at a very high level. Database has been upgraded to SQL Server 2016. We used Snowball to move the full backups of the database to the AWS site, and logs were shipped through VPN. The advantage of shipping the transaction logs through the VPN is the transaction logs were taken every 5 minutes, and they were smaller, so that we were able to send it over the VPN, which in essence uses the internet. And we also configured a high-performance database mirroring site within the AWS. The high-performance mirroring site was set up in a different AZ to take the infrastructure advantages given by the AWS itself. Part of this whole process, MAeHC and Datavail, we brainstormed about what is a topology or a technology within SQL Server we can use for implementing HA. One of the first things that came to our mind was using SQL Server Always-On Availability Groups. However, using SQL Server Always-On Availability Groups requires you to purchase Enterprise Edition of SQL Server, which is really expensive. So we collaborated with MAeHC, and we concluded that just using the SQL Server 2016 Standard Edition and at the same time configuring database mirroring, basic database mirroring using SQL Server Standard Edition would suffice. So the resulting design was high-performance database mirroring was set on all the databases, and we were replicating the data from one AZ to another AZ, which I'll show in the next slide. And this really reduced the costs of the enterprise licensing. This is the implemented database architecture in AWS. As you can see, the Microsoft SQL Server instances running on EC2 on AZ1 is a primary OLTP server. And all the applications were talking to these servers. And we set up the exact replica of these instances in a different AZ within AWS. And we set up the database mirroring in a high performance mode between the primary site and the HA site. When I say high performance mode, what it really means is the database has been set, the database mirroring configuration has been set as asynchronous commit, which means that the transactions are committed on the primary and then the transactions are replicated to the HA site asynchronously. In that way, you're not really affecting the performance of the primary database server, which takes all the OLTP workloads. As part of this whole process, we also spend quite a bit of time in archiving the backups because as a part of HIPAA and the PHI requirements, the databases has to be archived for more than 30 days. So the part of this process was moving the database backups to Glacier. I'm going to talk a little bit about that, how we achieved this. Datavail is responsible for taking SQL Server native backups and put it on S3 and eventually archive it to Glacier. And Logicworks, from their perspective, they are responsible for taking a snapshot of the server, and the snapshots were stored in S3 and which are then eventually moved through Glacier. This achieves two things. One is like you can have a long-term archiving process, and also you can have a really good cost optimization. So one of the major outcomes of this whole migration process was cost optimization in conjunction with a HIPAA compliant environment and also PHI data. So some of the actions we took was choosing the right sized Amazon EC2 instances for running the database servers, and also like Donovan said, like for running the web servers. Within the database layer, we choose the R4 high memory Amazon EC2 instances with provisioned IOPS for the data files, log files, and the TempDB. We ran in production using an on-demand model until we were really confident in the configuration in terms of CPU memory and storage. After a few months, we purchased the reserved instances to further reduce the costs. So the key takeaway in this whole migration process is the first thing is security, the second thing is the data migration, and the third thing is the cost optimization in terms of database and also in terms of the infrastructure. So we were able to achieve all of those three in a very successful way. Some of the post-migration activities we did was implementing custom Datavail database monitoring tool on the database servers. What this does is this monitors the database 24/7 and sends an incident whenever it happens. The good example of an incident is database transaction logs being full or the database being offline. So like I said before, Datavail has a 24/7 incident monitoring and response team, which picks up the alerts and respond to it immediately. We're also tasked with doing ongoing performance tuning, which involves query tuning, rate statistics analysis, and TermDB optimization. We're also doing proactive tasks in terms of index and statistics maintenance, which also involves carefully analyzing the indexes that are required for the OLTP workloads and also doing the defragmentation of those indexes. Logicworks, from their part, they're involved in 24/7 cloud operations with the support from the NOC Center. Logicworks is also tasked with maintaining the ongoing HIPAA compliance audit support, which includes monitoring, patching, and ticket support. MAeHC, as we said, they wanted to design a really highly scalable environment in AWS so that they can take customers down the road. So onboarding the future customers to the MAeHC platform is also a responsibility for Logicworks and Datavail, which we have been doing. With that said, I'm going to open up the floor for questions and answers.
Thank you so much, Siva, also to David, Donovan, and Zlatan. I want to remind everybody that you can submit questions in the Ask a Question panel on your screen. And I will start with our first question. Has the infrastructure been third-party reviewed or tested for security aspects? I'm not sure who would like to take the question.
Hey, Donovan, do you want to take the infrastructure question?
Sure. I'll answer it. So we build all of our environments to HIPAA and PCI compliance, and then we actually have a third-party auditor who audits for HIPAA compliance. So yes, it has been audited. Otherwise, it would not be able to qualify as HIPAA compliant.
Okay, thank you, Donovan. And we have time for just one more question. And it is, when we pick first choice for our databases, is there PHI data? How do you guys handle that? Do you encrypt and store the data?
Yeah, this is a very great question. As far as choosing the database platform, we typically recommend stay with what database platform you're on right now. So in this particular case, MAeHC was using SQL Server as a database platform. As far as meeting the requirements for HIPAA compliance, the data has to be encrypted at rest. So the encryption of the data at rest can be handled by using transparent data encryption, and also AWS provides a way of encrypting your data at the storage level or at the disk level, which is encrypting your whole disk, whole EBS volumes. So that's one aspect of it. As far as implementing the data encryption in transit, you can implement SSL encryption, which will encrypt all the data that's transferred over the network. This, in majority of these cases, these both encryptions would satisfy the HIPAA requirements.
Okay, thank you.
This is Dave. Sorry, I missed the first question. My phone disconnected. Did that first question get answered about the external security review?
Yes, it did.
Okay, great.
I believe, unless you want to take that, but I think we're all set.
Sure. I guess I would just say that yes. The short answer to that is yes. We have an external security firm that reviews our environment and did a full review of the AWS configuration and external security and internal security of that environment when we did the migration.
Thank you, David. At this time, we do have to wrap up. I want to thank all our panelists for a terrific presentation. For those listening, be sure to complete the evaluation at the conclusion. Share your thoughts. And as a reminder, this session will be available on demand until next year, August 12, 2019, through the HIMSS Learning Center. Thank you, everyone, and have a great day.